y square. Now this is a function of y. How can I differentiate straight away with respect to x? I cannot. I can differentiate with respect to y. It's a function of y, no? Same strategy. D of y square. Just keep dx here. This dx I kept here. Divide it by dy, multiply by dy. And you get your answer. So what is the derivative of y square with respect to y? It is 2y. And this dy by dx remains as such, because we don't know the value of y. It remains as such. So all the questions can be done in that way. That is primarily the reason behind what we are doing. This is formal way, but in general we say just go on inside step by step. Like in this thing, if we have to differentiate it, first we will break it. We know derivative breaks over addition and subtraction. Now guys, what is the derivative of cos y? First you differentiate cos, that is minus of sine. Inside you remain keep y as such, into then derivative of inside term, that is dy by dx. Now what is the derivative of y square? First you differentiate square, that is 2 into y. Then derivative of y, inside term, like that. This is your answer. So that is how primarily chain rule works. It goes on inside. Before I do any more example, or I give you any example to do, let me take last example. D by dx of sine of ln of y square plus 1. So guys, what will be derivative? First you differentiate sine, it is cos, and remain everything inside as such. Do not disturb it. Multiply. Then you differentiate ln. Derivative is 1 by whatever is inside, into. Then you differentiate y square plus 1. Now here is the game. Derivative of y square plus 1 will be 2y into dy by dx. This is the main term. This is a term you need to be careful about. What is the derivative of y square? Don't forget, you are differentiating with respect to x. So derivative of y square will be 2y into dy by dx. Okay guys. So that is the first thing about chain rule. Now I'm going to give you one question to do. But before that, I'm giving you one observation. If you want to differentiate x into y with respect to x, how will you differentiate it? Product rule. One function is x, another function is y. Product rule. There are two things. Try to see y will be some function of x. So one is function y, one is function x. Multiply them, you get x into y. So these are two terms. So x into derivative of y, which will be written as this, as you are differentiating with respect to x, plus y into derivative of x. It will be 1. Derivative of x with respect to x is 1. Right? Okay guys. So I've given you a brief about first side of chain rule. How do we normally proceed? So now is your turn. Find it in your rough copy. Do it in your rough copy. Derivative of sine of xy. These are your options. Okay, guys, so which option do you think is correct? Okay, so last few seconds. Okay, so not at all bad. Those who marked A, I am a bit unsatisfied, but rest are good. First of all, answer is C. How to do that? Simple. It is sine of something. So first we will differentiate sine. It is cos. And keep that inside thing as such into derivative of this inside term. And we just did derivative of this is nothing but x into dy by dx plus y into 1. Simple. So that is chain rule. When you have something really bad inside the function, if it is only sine x, derivative is cos x. We are done. But if it is bit bad, it is not simple x, it is something else, then you have to go inside and take its derivative as well. That is the whole idea of chain rule. Talking about it formally, let me once again conclude. Say you are differentiating some function of y or whatever it is, okay, but with respect to x. That is whole thing I'm doing in the last slide. Try to see, inside we have something in terms of y, but we are differentiating with respect to x. So whenever we are differentiating some function of y with respect to x, try to understand we cannot differentiate straight away. Okay, we just take this dx here and divide, multiply by dy. That ways this becomes easy to differentiate now. This additional term is here. This is the only thing you need to take care about. Okay, so let us see another phase of chain rule, kind of similar, but another phase, like this. Those who have done chain rule might be like very comfortable with this phase. cos of ln of x, sine of tan of x, sine x whole square, ln of cos of x square minus 1. All is about function inside function. This is a function inside cos. This is a function inside sine. This is a function inside square. Here we have two functions. Chain rule is all about these things. When we have a function inside a function. So just as I told you, first you differentiate cos. It is minus sine, but keep the inside thing as such. Then multiply by derivative of inside term, 1 by x. Sine of tan x. First you differentiate the outside term, cos, keeping the inside term as such. And then you differentiate inside term. Again here, guys, first we will differentiate power and then inside term. There might be a function inside function and another one function more inside. Same procedure. First you differentiate ln 1 by cos of x square minus 1. Then you differentiate cos minus sine x square minus 1 multiplied by derivative of x square minus 1, that is 2x. Guys, I suppose it's very easy to understand now. That very simple strategy is that, and you can do it now. I know that. Let me relate this thing with something we just did. You do nothing, call it y. Y कह दो ln of x को. Let us call ln of x as y. So this question is d by dx of cos y. Y is another function of x. Try to see, y is function of x. Now as we did in last slide, it is differentiation with respect to x. Okay, so dy and then you differentiate it. If I do it formally, otherwise I would have straight away written the answer also, but just doing it formally, dx taken here, dy multiply divide. Now what is derivative of cos y with respect to y? Minus sine y into what is derivative of y with respect to x? Guys, this is y. It is 1 by x. So keeping the value of y, we get the answer same. So it is same actually. Okay, but this approach is more important because students normally get confused with y. They just miss it. You need to see y as a function of x. Okay, of course you may straight away write the answer here. First you differentiate cos, keeping y as such, and then derivative of y. Let me write dy by dx first of all. And dy by dx from here, ln x. That is all about chain rule first of all. Okay. Now I'll be using these concepts of chain rule in the next category. But before that, guys, if possible for you, you just tell me, did you understand so far what we have done? Okay, that is great. So about 15 students have some doubts. The rest are fine. Okay. Students having doubt in that, don't worry, beta. The doubts will be clear in the next kind, because it will be used over there. They'll be telling you how am I using it. Next little concept is derivative of f with respect to x and f dash. Are they same or not? That is the concept. Listen guys, first of all, let us see what is f dash. Listen, let me just write fx as x square. Then when I say f dash at 2, or let me take 3, what do we mean by that? Okay. F dash at 3 is the notation for derivative of f when x is 3. That is, first you differentiate it. First you differentiate it. Now what is the derivative of x square? It is 2x. So now you put x equal to 3. So 2 into 3 equal to 6. If I ask f dash at t, what it will be? It will be derivative of fx at x equal to t. So it will be 2 into t, that is 2t. What will be now, guys? Please be careful. Now if I ask f dash of sine x, what does it mean? It means derivative at sine x. So it is 2 into sine x. Now in place of x, you will put sine x. So when it is f dash 3, you put 3 in place of x. When f dash t, you put a t in place of x. When f dash sine x, you put sine x in place of x. That is f dash at whatever it is. First you find derivative and then you put x की जगह पे वो element. Now let me come to this example. If I say f of x is sine x, then we all understand f of x square will be sine of x square. Now guys, when I ask f dash x square what it is derivative of fx at x square. This is very important point. It is derivative of fx at x square. So what is the derivative of sine x? It is cos x at x square. Now you put x square in the place of x, cos of x square. Certainly d by dx and f dash are two different things. Try to see if you want to find this. I'm just comparing. This is f dash at x square. This is d by dx of f of x square. So primarily you are looking for derivative of sine of x square. Now guys, you know chain rule. It is sine of x square, function inside function. So first you differentiate sine, that is cos, keeping the inside term as such. Multiply by derivative of inside term. Now what is the derivative of x square? It is 2x. Try to see, certainly they are not equal. And indeed they are not. They are different things. So you need to be careful about f dash and d by dx. Okay, they are not always same. Okay, so that was like the comparison of f dash with d by dx of f. That is a difference. Now let me just give you an example and further clarify this thing. You want to find dy by dx. F dash x is given. It is 1 plus x upon 1 minus x. Okay, how to find dy by dx from here? Y is f of sine square x. You want to find dy by dx. So differentiating both sides with respect to x. So primarily this is something we want to find. Now the issue is, how should I find dy by dx of f of sine square x? That is the issue. Okay, guys, let us do one thing. Somehow this sine square x is troubling me. Had it been x, I am happy. But it is sine square x. We apply chain rule. Just see. First differentiate f, keeping inside term same. F dash, keeping inside term same. Multiply. Then you differentiate inside term. Derivative of sine square x. I hope you understand it is 2 sine x into cos x. First power differentiates and then derivative of sine x. Now guys, if f dash x is this, what will be f dash sine square x? You will keep sine square x in place of x. Just look here. What is f dash sine x? You just keep sine x in place of x. So it will be 1 plus sine square x upon 1 minus sine square x into 2 sine x cos x. And this is your answer. If you understand this slide, you might take a screenshot better, you might require more time. If you understand this slide, no, believe me, any good question of chain rule will involve such things only. If you understand this slide, half of the problems are gone. Okay, so that is how we proceed in the question which involve f dash. F dash should be very clear to you. Take a minute, just look at this question first and then this question. Take a minute. Good. Hey, 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 hey. So, okay guys, Very good, very good. Okay. So guys, moving ahead, basically this is a formal definition of chain rule. Okay, but now we need not worry about it. We have done it. So this is a formal definition you will see in the books, but that is how we use it. I just showed you. Okay, so don't need to remember these definitions now. We are pretty much clear about that. Guys, now I'll show you how that chain rule is required for all other formats. Okay, what is the importance of chain rule? See, implicit differentiation. Implicit mean when your expression is mixed in x and y, it is not of the form y equal to fx. This is explicit, that y is expressed properly in terms of x. This is implicit, when x and y are like sitting mixed. You are not writing y in terms of x separately, they are just mixed. Now, how to find dy by dx from here? One is proper method, which you need to apply in school, and of course you can apply in competition as well. One is shortcut method. Before I tell you shortcut method, let us do it first by proper method. Listen, just differentiate overall with respect to x. What will you get? Just see step by step. We will get d by dx of x cube plus y cube is equal to d by dx of 3axy. Okay. Now we know we can break it. This is derivative of x cube plus derivative of y cube. Now guys, here you must be seeing chain rule coming into picture. Okay, let me just keep this thing as such. Okay, guys, now tell me, of course you cannot tell me, of course, derivative of x cube, it is clear, easy, 3x square. But this is where you need to be careful, because it is in terms of y and not in terms of x. So first you differentiate cube, it becomes 3y square. Then you differentiate y also, it is inside term now, dy by dx. That is all you have to understand, and that comes from chain rule. Okay, so derivative of y cube with respect to x, this is crucial. It is not just 3y square, because it is not x here, it is y, it is some function. See y as some function now, because you are differentiating with respect to x. So y is some function. So here derivative of inside term will also be there. On the right hand side, 3a is constant, and we just did the derivative of x into y with respect to x. Product rule, x into derivative of y plus y into derivative of x. So this is what you get when you differentiate overall with respect to x. Now do nothing, just collect the terms containing dy by dx. Just collect the terms. So on left hand side, I have 3y square, and on right hand side it is 3ax. So let me just take it on left hand side and keep everything else on right hand side. 3ay minus 3x square. So you get your dy by dx as 3ay minus 3x square upon 3y square minus 3ax. That is your answer. Before we proceed ahead, let me give you the shortcut. Okay. Guys, shortcut is when your function is implicit, let me call it f of x comma y, because x and y terms will be like combined. If you have such function, then derivative of y with respect to x is obtained as minus partial derivative with respect to x. Sorry. Yes. Okay. Divide by partial derivative with respect to y. This. Now, what is partial derivative? I just explain it through the example. Let us do this example again. X cube plus y cube equal to 3axy. X cube plus y cube equal to 3axy. And we want to find derivative. First of all, write everything on one side like that. Now this is your f. Now my formula says derivative of such function, if f is equal to 0, then derivative of y with respect to x is minus partial derivative with respect to x divided by partial derivative with respect to y. Now guys, partial derivative means only x is your variable. Anything other than x is constant. Is constant. So now just differentiate it, seeing x as variable and every other term as constant. Minus derivative of x cube, 3x square. Derivative of y cube, but x के respect में 0. Only x is variable, else everything is constant. So y cube is constant now. 0. Minus partial derivative of 3axy. When I say partial derivative, only x is variable, rest everything is constant. You know constant comes out. So this will come out. So the derivative of x with respect to x is 1. It is 3ay. Divide by partial derivative with respect to y. Obviously, only y is variable now. So what will be derivative of x cube? 0. What will be derivative of y cube? 3y square. And what will be derivative of 3axy? Now 3ax will come out being a constant, and derivative of y with respect to y is 1. So this is your answer. 3ay minus 3x square upon 3y square minus 3ax. Clearly 3 gets cancelled, and this is your answer. So that is how we use this shortcut. Try to see, same answer is here. Exactly same answer. Of course, do not apply this in school. Not for school. It's not need for speed, okay? It is not for school. Do not apply this shortcut in school. So that is how it is done in school or in competition as well, and that is like somewhat a short method to find derivative in case of implicit functions. Guys, now this is a question which will certainly help you in like removing some of your ambiguities in differentiation objective questions. Guys, in differentiation, no, when you will attempt some objective questions, it will normally happen that you would have done it correctly, still your answer will not match. Okay, it is very common. That does not mean at all that your answer is wrong, first of all. It might be, but not generally. Like in this case, try to see if sine y is equal to x sine a plus y, then we got to prove derivative if this derivative is this as well as this. It has two different shapes. Okay. First of all, let me just prove the direct one. B part. It is direct. I'm applying shortcut now, okay, so that you just practice that shortcut thing. I just took everything on left hand side, and now I'm applying the shortcut formula. Dy by dx is partial derivative with respect to x divided by partial derivative with respect to y. Okay. Now when you take partial derivative, first of all, sine of y is constant now. Only x is variable, rest everything is constant. So 0 minus. This term is constant now. It will come out. So minus sine of a plus y comes out into derivative of x. That is 1. Divide by partial derivative with respect to y. So what will be the derivative of y? Sine y, cos y, minus derivative of this with respect to y. X is constant now, it will come out. And derivative of sine of a plus y will be cos of a plus y with respect to y. And that is something you have to prove. Guys, pick your rough copy and try to find this partial derivative yourself and match with what I've got. Okay. Do it right now. Pick your rough copy. This is your F. Apply this formula and try to see, do you get the same thing? Okay. So just tell me, did you understand how this shortcut formula is being applied? Do you understand now how partial derivative is like applied? Not the reason how this formula came into picture, but how we are finding partial derivative. Did you understand that? Okay. So about 15%, about 3 to 4. Okay. ठीक है. Okay, about 25 to 30 students out of 200 has some doubt how this partial derivative is being found. Okay, look dear, let me just give you a brief explanation of this thing. Try to see, when we are partially differentiating with respect to x, it is this minus partial derivative of this. Okay, partial derivative of this with respect to x. When we find partial derivative, no, only x is now variable, everything else is constant. So just look at it as constant because it does not involve x. If it does not involve x, it is constant. So its derivative will be 0. Okay, now minus. Try to see, this term does not involve any x. If it does not involve any x, it is constant. That is the whole idea behind partial derivative. When we are finding partial derivative with respect to x, only x is variable, rest everything is constant. We know constant comes out. And we are left with partial derivative of x with respect to x, that is 1. That is how numerator is written. Similarly, you work on denominator. And now this second thing. Look, there are two ways of getting a. One, you just observe that everything here is in terms of y. It is not involving x. So what do I do? From the given equation, I just take y on one side, complete y on one side. Like that. Now you find dx by dy, that is differentiate with respect to y. Simple quotient rule will be used, no chain rule at all, because it's y only and we are differentiating with respect to y. When you apply this quotient rule, you will get this. Sorry. Okay, you will get this. Just apply quotient rule, you will get this. And now guys, we clearly know dy by dx is just a reciprocal of dx by dy, nothing more. It is simply reciprocal. Okay, so this is your answer. That is what we wanted to prove. So sometimes before straight away differentiating, we require to manipulate it a little bit so as to match what is required. But sir, if it doesn't strike us that we should have written it like that, first finding dx by dy and then taking reciprocal, getting dy by dx, then what? What if we proceeded like that? Now the second thing. Whenever you differentiate, this is the right answer first of all. But if you require some other form, then you got to use the given equation here to get this thing. And what to use, how to use? Simple. You get this, but what we require does not contain x. So you remove x from here. How? By keeping its value from the given equation. That is all. Ho gaya, finish. Just take LCM, you will get this thing. This point is very important while doing objectives of differentiation. It will happen a lot of time. You would have done exactly the right way, but answer won't match. Then you need to see what is the difference between my answer and the required answer. Use a given equation to eliminate what you don't require, and immediately you will get the right answer, which is in the option. Okay, guys, I wanted to do parametric also, but I suppose I have to stop here because my time limit is over now. Only 2-3 minutes are left. Okay, I give you one last tip and then I'll stop. Last tip is, it's just like a question we done before. Dy by dx equal to this. Again, try to observe, we want to find derivative in terms of x only. So I will first try to express y in terms of x only. And for that, the important tip is, if you require to square, no, you may do squaring also. No issues with that. Like that. Now it is x square plus xy minus y square plus minus xy square. Okay, so now these two together and these two together, perhaps that's x square, and try to see here, this is x minus y into x plus y, and this is xy common x minus y. Clearly I can take x minus y common and I'll be left with x plus y plus xy. It cancels out because x is not equal to y, so I can just cross multiply it and remove it. And from whatever is left, I can easily write y in terms of x. And now I will differentiate to get my answer. So tip behind this question is, see what you require. Do not just straight away differentiate. Try to focus on what you require. You require only the terms of x. So first you try to just separate the terms of y and x. And for that you can do squaring as well. So moment I could express y in terms of x, well, I differentiated and I'm through. That's all. Okay. So guys, before I stop, I'll like to ask one thing. This. That is great. So guys, first of all, that is really good. Maximum students learned at least something. I'm really happy with that. And guys, before we leave, if possible for you, kindly tell me this as well. I'll be very happy with that. That is really good, really good. Thank you guys, that was really good. So I suppose the purpose behind my webinar is almost satisfied, justified. So you must have learned that you have to focus a lot on, first of all, chain rule. That is where you will certainly commit mistake, especially when it comes to y. Students generally miss dy by dx. Okay. And second is implicit function, these two things which I just taught. So with that, I suppose it's a time to say good night. And God bless you all. If you have any doubts, you can like ask me anytime. This is my number. You can send me your doubts on WhatsApp. If you have any doubt in today's lecture, or even otherwise, you may ask me any doubt. By the way, as I told you, it's Arvind Kalia, and from IIT Delhi. So anytime you ask any doubts, God bless you, keep learning, and